The neutron as a thread of reconfiguration and potential energy repository. In the Threads and Spinors theory, threads reach a max utility. Over time, threads and spinors, particularly spinons that stop spinning, non-spinning spinons, become energetically inactive and lose their ability to contribute to electromagnetic or gravitational forces. At this stage, they are no longer helpful in sustaining stable protons, electrons, or other highly energetic structures. Thread bundling as a natural recycling mechanism. When threads and non-spinning spinors reach their useful energy limit, they undergo a reorganization into a dense, neutral structure, a neutron. This process avoids waste in the universe by repurposing inactive spinons and excess threads into a state that holds potential energy. Neutron formation, a stability mechanism. The universe prefers stability and minimizes free-floating loose threads. Neutrons form as a gut-bundled structure to stabilize unused or decaying thread spinon systems. These neutrons, although neutral and relatively low in electromagnetic activity, hold latent potential energy due to the tightly bundled threads and non-spinning spinons. Potential energy storage. The neutron becomes a repository for potential energy. Similar to a compressed spring, non-spinning spinons can regain spin when perturbed, leading to beta decay, release of energy, electrons, and protons. Threads within the neutron remain under thread tension, storing energy that can be released during decay or nuclear reactions. Why neutrons exist? Neutrons exist because the universe is dynamic and cyclical. The threads and spinons naturally reach a state of maximum entropy, energy depletion. Instead of disintegrating into chaos, they self-organize into neutrons to await reactivation. Neutrons, therefore, are a temporary pause in the energy life cycle of threads and spinons, stabilizing systems like atomic nuclei and holding potential for future energy release. Refined definition of the neutron. The neutron is a gut-bundled structure of threads and non-spinning spinons that have reached maximum energy utility. Formed as a natural recycling mechanism to stabilize decaying systems, stores potential energy through thread tension and the latent ability of spinons to regain spin. Implications of this hypothesis: predictable neutron decay, beta decay, becomes a predictable process where latent spinons regain spin, releasing energy, electron and proton. Universal energy efficiency. The universe avoids energy waste by repurposing inactive components into neutrons. Role in cosmic evolution. Neutrons could represent an intermediate state for threads and spinons, participating in larger cosmic recycling processes like star formation, core growth, or supernova.